Hello. In this video, I'm going to explain problem 20 from the 2014 F equals MA contest. In this problem, we have a space station which is shaped like a wheel of radius r with all of its mass, or essentially all of its mass m at the rim, and we are told that it is desired to have the station rotating at such a rate that an object would have radial acceleration g to simulate Earth's gravity. And they're going to use two small rockets mounted on the station's rim, and we're given the thrust, and we're asked how long of a time is needed to fire the rockets to achieve this condition. So, first, we need to see what condition do we even need to have a surface gravity of g, or a gravitational acceleration. Well, when you are standing on the wheel, then you have a certain centripetal acceleration, which I'll label AC, but then, and if you have mass m, but then in your frame of reference, there will be a fictitious force, I'll label that F, little f, fictitious, this is in your frame, and that will equal m times that centripetal acceleration. And so this is the centripetal acceleration, and that is a fictitious force that you would feel in your frame. So I should clarify that. And so in your frame, of course, you would not see that centripetal acceleration. You would instead see the fictitious force. So anyway, centripetal acceleration is omega squared r. So this is r, this is m, where omega is the angular velocity, and we want that to equal g. And so we know that omega is going to be the square root of g over r. So that's the first thing. Now we need to see how long will it take to achieve an angular speed of omega. Well, we know that we're going to have two rockets, each giving a force of t, and so the torque generated will be 2, since there are two engines, times t times r, since r is the radius and the force is indeed perpendicular to the radius, this radius vector, and that will equal the moment of inertia, which in this case is mr squared, since all of the mass is at the edge of the wheel, and this is one of the moment of inertia that you should memorize, or moments of inertia. This is one that you should memorize, that for a wheel or some kind of hoop with all the mass on the outside, the moment of inertia of an axis, of a perpendicular axis that goes through the center, is mr squared, and then times alpha, where alpha is the angular acceleration. And so we can cancel an r, so we get alpha is 2t over mr. Now, how much time do we need? Well, that will be the desired angular velocity divided by the angular acceleration. And so what does that become? That becomes the square root of g over r, and then divided by alpha, so we'll get mr over 2t, and thus we get t equals the square root of gr times m over 2t. And let's go back to our options. So we have the square root of gr times m over 2t. And that is a correct answer. Alright, and that concludes this problem. Thank you for watching. I hope that was helpful.